Hi all. See this. This is a problem regarding a AP series. Okay. Maybe GP. Okay. So it's a problem regarding AP, GP, and all that stuff, right? So here we have to first note that few given information. So we'll take those each and every information separately, and then we'll proceed. Okay. So here the first information given that log of, right, B1, B2, B3, BE 101 all are actually in a AP series, right? So let's consider that. So it's given that log of B1, log of B2, and so on. We end with as log of B of 101 are in AP with common rate difference log of 2. So here instead of log we just convert it to ln because that's the normal interpretation we use, right? Because ln is actually stands for log something base e. Okay. Now see that let us take two arbitrary element, right? They are in AP. So it is obvious that log of bi plus 1 minus log of bi, it's definitely equal to ln of 2. Now, if I apply the properties of log, that gives you log of bi plus 1 divided by bi is equal to ln of 2. That's imply that bi plus 1 divided by bi is equal to 2. So what it's imply? It's imply that the consecutive terms of that B1, B2, B3, that series except the log is in a GP series because the ratio are equal, right? So it's a GP series with common ratio 2. Okay. So it's imply that then B1, B2 and so on, we are going up to B101 are in GP with common ratio 2. So that's the first in basic info. Now it says that also that we are required to find out, right, few important parameters or important terms in this series, right? What's that? You see that we need to compare between 101 term and 51 term, right? Because 51 is equal. Okay, so let's go ahead. So here let's calculate that what is the term called B51, the 51 term. So here B51 term is a 51th term of this GP series with first term B1 and common ratio 2, right? So therefore this term can be written as B1 multiplied by 2 to the power 50. And if I go ahead and trying to calculate B of 101, that's simply equal to B1 into 2 to the power of 100. Okay, because we know that init term of a GP series or the Rth term is equal to A1 plus 2 to the power or R to the power n minus 1 and all that stuff, right? So we know that, right? So that's it. So here we just calculate all those values. Now it says that again we need to calculate the AP series. So let us concentrate now on the given AP series, right? So in the AP series this says that A1 to A101, okay? So it says that A1, A2, and so on will have A101 is in AP. So let us assume that the common difference is D. Without lot of any generator, you consider that. So therefore, now it says that what is the A51 term here? So A51 term obviously be A1 plus 50D. And let's go ahead and take A100 term because also we need to compare between them. So let's go ahead and find out that A101 term that's equal to A1 plus 100D. That's it. So we calculate all those stuff. So one information we can easily calculate from here, that is what is the relation between that D, okay, because D is unknown here. How can we operate find do? We use these two information that A1 B1 is equal and 51 term is equal, right? So first equate A51 and B51. So given that A51 is definitely equal to B51. So that's imply that what is A51? That is A1 plus 50D is equal to B1 multiplied by 2 to the power of 50. Now as A1 and B1 are equal, that also another information. So we'll find if B1 plus 50D is equal to B1 multiplied by 2 to the power 50. Let's calculate that 50D here. So 50D is definitely equal to B1 taken common 2 to the power 50 minus 1. So the common difference, okay, we are obtained here. Now if we require D, we can divide by 50. So that's why that step is a very trivial step. We just ignore that. Now let us compare between A101 and B101. So take that, okay. So see that if I use this ratio, what will be our A101? So therefore my A101 will become A1 plus 2B1 2 to the power 50 minus 1, right? Also this term can be written as B1 plus 2B1 2 to the power 50 minus 1. That's it. So let's come back to that 101 term again in a very beautiful way. So let's go ahead and write that 101 term. So if I consider that, we'll find that B1 taken common. So let's take B1 common. It is 2 into 2 to the power 50. That gives you 2 to the power 51 and minus 2 and plus 1. So therefore that's it. And we already calculate that B101 is equal to B1 multiplied by 2 to the power 100. Now if I take that ratio in a normal way, 101 divided by B101, we can easily find it is 2 to the power 51 minus 1 divided by 2 to the power 100. That's it. Now it is obvious that 2 to the power 51 and 2 to the power 100 in that ratio is obviously less than 1 because this 2 to the power 100 is too big. Okay, so therefore it's less than 1. That's imply that A101 is less than B101. So one relation we are obtained. So therefore either A or maybe option B is the correct option. Now we have to find the relation between S and D. Okay, so if we go ahead and try to calculate that sum, right? So let's go ahead. So what is S and D? Okay, so S here is actually sum of the first 51 term in a AP series. So therefore S can be written as 51 divided by 2 A1 plus A51. Now A51 can be written as 51 by 2 A1 plus A1 plus 50. So here that 2A1 can be replaced as 2B1, right? Because A1 and B1 are equal. So 2B1 plus 50D already calculated. So B1 multiplied by 2 to the power 50 minus B1. So therefore, we can calculate my S is equal to 51 divided by 2 B1 multiplied by 2 to the power 50 plus 1. That's it. So we calculate S. Now see that operating with 51D is not common, right? So let's make little bit of changes. We take B1 out and 51 inside, okay? So that's the only tricks here we need to use. So B1 is equal to 51 multiplied by 2 to the power 49 plus 51 divided by 2. That gives me my TS. If I go ahead and calculate T, what's T? T is actually the sum of first 51 term in that given GP series. Now in that GP series, right, the formula if I use, we can find that it is a 51 term. So therefore B1 multiplied by 2 to the power 51 minus 1 divided by 2 minus 1. That gives me T is equal to B1 2 to the power 51 minus 1. That's it. So we calculate S and T. Now see that we need to calculate that the difference S minus T, because then only we can easily understand that which is greater than and less than. Yes, we can go ahead for the ratio as we did it for here, but here it is easy to calculate using S minus T. So let's go ahead and take S minus T. So what is S minus T here? See that it's B1 taken common. So we'll have 51 into 2 to the power 49 plus 51 divided by 2 minus 2 to the power 51 plus 1. So if I calculate that, we'll see that B1 multiplied by 2 to the power 51. So this gives you actually 53 divided by 2 plus. Now here we need to take a little bit operation. See that 2 to the power 49 and 51 is there. So you can take 2 to the power 49 common, right? So it will be 51 minus 2 square. That means 4. That gives you 47. So therefore you can write it as 47 multiplied by 2 to the power 49. That means that it's greater than 0. That means AC is greater than T. So that's it. So you calculate AC is greater than T and A01 is less than B01, right? So therefore, we can easily understand that in this particular case, right, obviously that option B is the correct answer. And that's it. Hope you understood the problem. Thank you.